We'll divide this segment into two parts. What do you think? Select a point around there to see what it's like. Very good. We could have chosen half, a third. This is a bit displaced, but it is close to an interesting proportion, which would if we have divided between two segments that we call A and B, if it turned out that the proportion between the large and the small was equal to the sum of the two. A plus B with respect to just the big one, we would have a very interesting proportion, which has properties such as, for example, if we go here again A, it turns out that this rectangle is proportionate, it has the same proportion. And now divide by 2 and we would also get this other one proportionate, and so forth and so forth. And this is a very interesting number, pay attention. For example, if we give B value 1, we have 2. We have a divided by 1 equals a plus 1 divided by A. And we solve this like a squared equals a plus 1. A squared minus a minus 1 equals 0. And this is a second level equation that can be solved very easily, right? How do you resolve it?
What is the value of A?
This number will change sign, 1 plus the square root of this squared, 1 minus 4 times this by this, minus 4 times minus 1, plus 4 divided by 2. And this is the most famous number 1 plus the root of 5, divided by 2, which is the golden ratio that we can calculate. Do you know what the root of 5 is? 2.5, right? Approximately 2.5, yes indeed. Not exactly if we put 5. In Excel we have a powerful tool for calculating square roots. So we call the root function root brackets the value to the left 5. We close the brackets and look at the number that comes out, 2 and a bit. Note that it has a lot of decimal places, but it has many more, it has infinite decimal places. Here it is interesting that if from this root of 5 we calculate the phi, the golden ratio equal to 1 plus this number that we have here. And all this divided by 2, then we have the famous number of divided by 2. Now we have it. We have a very interesting number 1.618 and loads more of decimals that in essence is what is called the golden proportion. And this golden proportion has lots of applications in the world of engineering, in the world of art, in the world of mathematics, in the world of nature even. Because if we go to, for example, Google, we look here in images of the golden ratio. Very good, I like that you know it. We see that it shows us a multitude of places where it crops up. See, in history of art, in architecture, in nature, in mathematics. Look at this snail. It is a very interesting world to explore, and I encourage you to do so, because it is truly surprising the quantity of things that have this famous number inside them, the golden proportion.
One question, but is it in the Vitruvian Man as well?
It will surely be there too. Very good question. Let's explore it.